Fine.
Yeah, got the right. Cool.
Alright, you're all good. All right, guys, we're gonna start.
Thank you, BB.
Enough fun for today. All right, so we're gonna do case 6A first.
We're doing new or old.
Old,
Why would
Thank
you
you.
wanna do the new one?
because old 6A is better. It's got everything.
What did you swear?
I did the same here.
Yeah. You're supposed to be our president.
Oh, the answers, did I? Didn't want to all the answers that are already.
All right, EE is ready for discharge and all antibiotics. Suddenly E develops a seizure in the hospital. Current serum creatinine is 1.3. Current height is 6'3" and weight is 208 pounds. So for seizures, gonna be doing phenytoin. So we're gonna do loading dose and then calculate a maintenance dose for him as well. All right. So in order to do loading dose, that's going to be, so it's gonna be 15 to 20. So you can just do 17.5 to get in the middle of that range. And then for phenytoin, we're gonna use actual body weight. So if we scroll up here, his actual body weight is 208 pounds. So 208 divided by 2.2 to get kilograms. $4.5. The loading dose here is going to equal 1653.75. So when doing loading dose for phenytoin, we have to make sure that it's in a denomination that we can give with either the chewable immediate release tablets or the suspension. So for this instance, just to make it easier for the dosing, we'll do 1600 milligrams. And then in order to figure out how many tablets we're gonna need, do 1600 divided by 50. So that's how many milligrams the tablets are. Yep. Yep. Is that good?
Yeah.
So 1600 divided by 50 is going to be 32 tablets total. So when dosing phenytoin, you have to remember that the most amount that you can give during loading dose is 400 milligrams, and then you have to repeat the dose every 2 to 4 hours until you reach your target dose. So 1600 divided by 4 is going to be 400, so we can do 4 different doses of the IR tablets. So the way that you would write your recommendation is give 8 50 milligram IR chewable tablets by mouth now and repeat Q 2 hours 3 times to reach dose of loading dose, sorry, 1600 milligrams.
Question?
Yep.
So we are doing the whole 6A,
This is the old 6A, yeah.
but why are you putting like 17.5? It's not supposed to.
Yeah, so between, so for phenytoin, the loading dose, when you calculate it, it's supposed to be between 15 and 20 milligrams per kilogram. So what I do is you can either calculate the range, which is perfectly fine, or what I do is I do 17.5 because it's right in the middle. And then whichever way you round, you'll be fine.
Oh.
Yeah,
So it's basically saving us time.
pretty much, yeah.
I have a question.
Yes,
If we were to do the oral suspension,
yeah, we can do that. You wanna do the calculation? Yeah. So since we know that we want to give 400 milligrams, so what we would do is the oral suspension. So the oral suspension is 125. 125 milligrams over milliliters, right? Per 5 mLs. So we want 400 milligrams per dose times 5 mLs over, what is it again? 125. And we want to solve for milliliters, so you do 400 times 5 divided by 125. So it's going to be 16 mLs. So the way that you would write your recommendation is give 16 mLs of solution by mouth now. And repeat. Q 2 hours. 3 times. And then also what's good practice is when you write the 16 mLs, just signify how much that is in the milligrams.
we actually.
Oh, yeah.
Yep.
So, if you have David's questions, put it in the chat, Tom's watching.
Yeah, and if you guys have any questions on the Zoom, feel free to either unmute yourself or you can put it in the chat.
Question.
Yep.
So once we do the loading dose, right?
Yep.
We find the dosage in milligram,
Correct.
and then we have to also do it. in milligram.
So these are two separate things, right? So this one right here, this is the oral suspension. This calculation here is for the IR tablets. So when he asks for a loading dose, an oral loading dose, you can do either one. It doesn't matter. You do one or the other. You either do the IR chewable tablets or you do the solution. Doesn't
Oh,
matter.
I can do both.
Either or,
choose.
not both, either or. You can choose. Yeah. Yep. Good. Any other questions?
Maintenance, right?
Yeah, we got to do maintenance. Yep. All right. Any questions on the Zoom? You guys good? Like I said, feel free to unmute or whatever. Okay, now we're gonna do loading dose. Yes.
I am, Teresa, you said, did Dr. Sun specifically indicate how he wanted directions written? Or is that just generally?
Yeah, so I didn't really go over his answer key, but I'm pretty sure this is how he wrote it, from what it was in class.
From what I remember, it was, he did, for like example, he did the oral suspension.
Yep.
And he did, 400 milligrams of the, 125 milligrams over 5 mils oral suspension,
Mhm.
then before it for 60.
16 mils. Yeah.
I think he wants the amount of, like capsules each dose.
Yeah, yeah,
Did you write that?
yeah. So give 8 IR chewable tablets. Give 8 50 milligram IR
Yeah,
chewable tablets.
okay,
Yeah.
cool.
Yeah, so if you write it like this, you'll be fine. So he wants to know the milliliters and the milligrams that you are getting. The one of those. All Right, so now for the loading dose, so for loading dose for phenytoin, you have to be between 5 and 7, I believe.
Maintenance dose, right?
Yep, maintenance dose now, yep, so it's between 5 to 7 mg per kg per day, so just use 6 right in the middle. 6. And then again, this is times the actual body weight, which is gonna be 94.5. Yeah, yep, 94.5. 4.5. So this is gonna be 567 milligrams. And just like before, we want to make sure that this is able to, we want to make sure that this is able to fit within the available formulations that we have. So for extended release, we have the 130 milligram ER capsules. So we're just gonna round this to 600. 600 milligrams. So the way that we would write our directions here is give 3 100 milligram ER capsules by mouth. BID. Any questions? Does that make sense? So something to remember about the maintenance dose for phenytoin is that if your dose is greater than 300, that's when you split it. So if you, and then the max dose for a single split is 400. It's very confusing and he didn't explain it good in class at all.
So like
Just, yeah.
basically if it's 300 over 300.
If it's over 300, you have to split it.
So just
Not a
need-
single dose doesn't know supplements.
No, so it's like this, right? So if the max, so if your dose is 300, you can give it at once. But if your dose is 400, then you have to split it up, BID.
That's how I would just explain it as like 300 is the max.
Right,
Yeah.
but if you have 800, you can do 400 BID.
Right, so,
Yeah,
which makes no sense.
right.
I think, I feel like I wouldn't do that.
I think it's just like you need an even number.
So if you have 800 milligrams as your dose, you would do 400
Milligrams you can't do.
milligrams BID. If you have 400 milligrams, you would do 200 milligrams
That's why it's, no,
BID.
that's why if it's not.
But if you have 300 milligrams, you can give 300 milligrams daily. Like that.
That's the only one that you can get.
Right, 300 is the cutoff. As soon as you go over 300, you gotta split. Yep.
I think you want.
Tommy,
That makes sense.
Tommy, split?
Split, we split, let's try to change, they'll do it.
Oh, we split eights, right? Split eights.
Yeah, you're always splitting eights.
Eights. Huh?
For when you split like the doses, so like, oh, okay. 300 milligrams down, you know, if there's a specific amount of hours you have to wait.
Just write BID. And you'll be fine.
Yeah.
He didn't specify.
But the, what about for minimum of 6 hours, but
That's for the Jackson, the 6 hours.
So for the loading, there was that specific,
Loading dose.
is that like 2 to 4 hours?
yes.
Yeah, so it's 2 to 4 hours. So he used 2 in class, but as long as you either do 2, 3, or 4, you'll be fine.
Yeah, the max, you can split it.
Yep. Yeah, right here. Yes.
Oh, okay.
Yeah, so your maximum for loading dose is 400 milligrams at once. And then you gotta split it. Any questions on the Zoom?
Hi, yes, I have a question.
Yep.
I don't know if this, if we will be asked this, but what if we get like a maintenance dose of 500? So how would we split that?
Yeah, so what Dr. Sun said in class is that it's okay to do uneven dosages. So even if we got 400 in class, he said that it would be correct to break it up to 300 in the morning and then 100 in the afternoon. But he said that if you're on a maintenance dose, it's typically the patient giving it in class or giving it to themselves at home. So you would want to make it even doses, so it's even for them or easier for them to remember how to take it. But he said that it's completely appropriate to break it up into 300 once and then 200 in the afternoon. So that's how you would do it. You don't have to make it even.
Oh, okay, got it. Thank you so much.
What'd you say?
Oh, I said thank you so much. I got it. Thank you.
Absolutely. Yep, so 500, you can break it up, 300 in the morning, 200 in the afternoon, however you want to do it. Any other questions before we move on?
Do you think there's ever gonna be a time where you have Lincoln's more than 900?
He could. I think there might be one. But then you would just write 300 in the morning, 300 in the afternoon, 100 at bedtime.
What do you ask?
If you got like 900 milligrams. So you take 300 in the morning, 300 in the afternoon. But I would really recheck your math if you get something like that, just to be safe, because
Right.
we haven't gotten an example like that.
Yeah, your profit should be
It's pretty
there.
high. I think the highest we've gotten is 600.
Yeah. We got 800 for one.
Yeah.
Which is when he did 400, right?
400 BAD. Yeah.
Jacob, another question from the chat.
Yep.
It's just, are you able to go over vancomycin and anything like that?
Yep, so Lisa, in the old cases, there is everything, so we have, I think there's. Phenytoin, in a minute, there'll be aminoglycosides, there's gonna be vancomycin calculations and digoxin. So these cases have like everything, I don't know why he didn't give us this in class.
Yeah,
To review.
who's fighting us on it?
Yeah. Yeah, okay, any other questions before we move on? So. So this is when a patient has low albumin. So just remember that low albumin begins at less than 4.0 grams per deciliter. So now we have to calculate the true phenytoin calculation. This equation is on our equation sheet. Let's see here. Adjusted.
It's right below the second towel.
Adjusted concentration equals actual phenytoin, which is 9.1 divided by 0.2 times albumin, which is 1.9 plus 0.1. Then all you got to do, just plug and chug. All right, what'd you guys get? Yep. 18.96 milligrams per liter. So just remember, be comfortable with the units because he asked for units on the last exam. And then remember, so when we go to K's, you need 3 decimals, concentrations, we need 2 decimals, and then everything else just 1.
No question.
Yep.
So, I know we only have practice the albumin one.
Yep.
And the equation sheet, you can put the one about the grant clearance for like renal,
Yeah, so if there's renal failure, the only thing that changes is this right here, that changes to the 0.1 instead of 0.2. So that's when creatinine clearance is less than 10.
he has never actually given a.
So what he said in class is that he will make it very clear which one he wants us to use. Like he will specify patient is in critical renal failure or whatever the proper wording is.
What I'm saying is that, it's not on the equation sheet, so like you should.
Yeah.
Yeah, so you know that.
Yeah, just make sure,
Same thing, just.
it's just that the 0.2 is 0.1. Yep,
Wait, say it again, so 0.2, it's what?
if there's renal failure, so creatinine clearance of 10, sorry.
0.2, yes.
If creatinine, it's 0.1. So this 0.2. This one right there
Yes.
turns into 0.1 if creatinine clearance is less than 10.
Oh.
Okay. All right. So EE aspirated.
The same.
One second, I gotta log into my OneNote. Right, EE aspirated during the seizure and now has pneumonia again. The physician wants to start him on ODA, tobramycin. So ODA just means that your tau is going to be 24 hours. The MIC of the pathogen is 2. Calculate EE's initial tobramycin dose, round to the nearest 5 milligrams. All right, so in this case, you just have to recognize that tobramycin is an aminoglycoside. The MIC is 2. So remember that for aminoglycoside, you want your peak concentration to be 8 to 10. You want your 8 to 10 milligrams per liter times the MIC. So in this case, it's going to be 2. So what I do is I just choose 9. Because that's usually what we did in class for these calculations. So you do 9 times 2. So your target peak is going to be 18 milligrams per liter. Huh?
Oh, wait, yeah, we can start.
This is the target peak.
Oh.
Yeah. Okay, so for this, since this is the patient's first dose, we're gonna use the population dosing. So we have to do find the elimination rate. In order to do that, we have to do the creatinine clearance for the patient. So the patient is 6'3", so we have to find their ideal body weight. They're a male. So IBW equals 50 plus 2.3 times 15. Ideal body weight. Ideal body weight will equal, let's see here, 2, 3. So ideal body weight is going to be 84.5. If we do 84.5 times 1.3, that equals 109.9 kgs. So since this is less than 94.5, we're going to use ideal body weight for our creatinine clearance calculation. So now we can calculate creatinine clearance. So 140 minus, what's the age of the patient? 48, thank you. Minus 48 times 84.5. What's the serum creatinine? 1.3. 72 times 1.3. So the patient's creatinine clearance 140 minus 48. Let me know what you guys get.
83.1.
Perfect, yep. 83.1 milliliters per minute. All right, excellent. All right, now we have to find the elimination constant. All right, so Ke. So for aminoglycoside, it's going to be 0.00293 times creatinine clearance, which is 83.1. Plus 0.014. Let me know what you guys get for the creatinine clear or for the elimination rate constant.
5-7.
What'd you say?
0.257.
Perfect, yep. What's the unit on that? Hours negative. All right, now that we have KE, we can calculate our rate of infusion that we're looking for. So that's going to be the long equation.
Wait, is it gonna be on the
Yeah. So final is cumulative. So anything that was on the last exam can be on this one. Yep. The stuff for this though, it's not bad. Everything's on the formula sheet. The only thing that we have to remember for these is the VD. The volume of distribution. All right, so we also have to calculate the VD for this patient. So for aminoglycoside, the VD is 0.24 liters per kilogram. 0.24 times the actual body weight, or times the ideal body weight, sorry. So that's going to be 84.5. So what's really important about this is that anytime we use ideal body weight, even if we use adjusted for creatinine clearance, you still use ideal body weight for the VD calculations. So it's the same thing for aminoglycosides and for digoxin. Even though we use adjusted for creatinine clearance, we still use ideal body weight for VD. Any questions about that?
How do you know when to use the 0.24 versus the long equation?
So we need to do 0.24 to get VD in order to do KO over time infusion, because VD is one of those variables in that equation.
Right, but I mean, like on the equation sheet, like.
Yeah, so this is for, so the 0.24 is for population. And then when we actually want to do like individualized, then we need like a specific VD of the patient. Questions in the chat? All right, what did we get for the VD? 20.3. What'd you guys get for VD?
20.3.
20.3, okay. 20.3. Unit on that is liters. Okay, now that we have all of our different variables, we can do KO over time infusion equals. So our C peak desired, which is 18, times the KE, which is 0.257, times the VD, which is 20.3, times 1 minus E to the negative 0.257 times tau, which in ODA is 24 hours. This is all going to be over 1 minus E to the negative 0.257 times the time of infusion, which is 1 hour. So the time, the KO. Oh, sorry guys. KO over time infusion equals,
Yeah.
let me know what you guys get.
I got 413.1. Sir,
We got 413.49.
you round down to 4 down. Round it to 600.
Just eyeball it, actually. Tell the nurse that, to,
Tell them she's.
let their nurse the nose.
What'd you guys get?
I got 413.1.
Yep, is that what everybody else got? Right, so this will be 413.5. And then we have to round to the nearest 5 milligrams. So what did you round it to?
415.
Perfect.
Milligrams.
Which is about 415 milligrams.
It was over 1 hour.
Yep, infusion over 1 hour. Yeah, so we can just ignore this part right here because it's gonna be 1 hour.
Yeah.
Yep, perfect, guys. Good stuff. Any questions about how we calculated the dose for the patient, why we rounded, anything like that?
This. Like, sir, yeah, like time for that. Yeah, but like.
All right, cool. Do you guys have any questions here? Good? Okay.
What are they fighting?
Okay, now calculate the concentration, peak steady state and trough using EE's rounded tobramycin dose to achieve your appropriate levels to treat the infection. All right, so C peak, this is all on the equation sheet here. C peak steady state equals 415 times
This one.
1 minus e to the negative 0.257 times time of infusion of 1, all divided
It's supposed to be the same.
over KE, which is 0.257
Sorry, we're only three.
times 20.3 times 1 minus e to the negative 0.257 times 24. So C peak steady state equals let me know what you guys get for the C peak.
18.37.
Yeah, we're interested.
Did you calculate the theories?
Yep. Right, gram per liter, excellent. All right, once we calculate C peak, we gotta calculate C trough. C trough steady state, so it's gonna be 18.07 times E to the negative 0.257 times the tau minus time of infusion. So it's gonna be 23. You know what you guys get for trough?
You're fine.
All right, so our trough steady state is going to be 0.05 milligrams per liter. Is this good?
Amazing.
It's perfect, right? So remember, we want our peak between, in this case, between what is it, 16 to 20, and then we want our trough to always be below 0 or below 1. Can't be below 0.
Right.
Below 1.
Imagine negative growth.
Yeah, negative trough, yeah.
Negative. Make sure your trough isn't higher than your peak.
Yeah, if you calculate that your trough is higher than your peak, redo your math because you're wrong. Someone.
or if he asks in a question, like he gives you peak and trough, and even before calculating, he might ask.
Mhm.
Are these like expected values or something, or did the nurse like adjust it correctly?
No, but he's never done that before. And you
Yes,
said
no, he has.
Pretty, like,
I think he has.
Yeah.
Like, were they,
Practice question,
um,
where he asked this, he's like, oh, are these like good values, or are these expected values?
Yeah.
And the answer was no, so it was like, okay, well, then tell the nurse, like, how do you correct the nurse to draw correctly?
also,
Just
just,
use one question.
also be careful, there was, a couple questions where the tau that we calculated, or, so this is gonna be for individualized. The new tau that we calculated was like 24.4. And I know that like he said to like almost always round up, but sometimes you have to go back to 24 to get better peaks and trough. So a good way to double check your answer is by always calculating the peak and trough that you get. Making sure that your peak is where it's supposed to be and your trough is supposed to be where it is, or where it's supposed to be. Alright. Alright, so what's your specific recommendation for tobramycin dose, frequency, and calculated levels and time to drop peak? So in order to do this, we have to go back here and calculate the half-life and time to steady state. So T half-life is going to be 0.693 over 0.257. So the T half-life equals
2.7.
Yep. 2.7 hours. And then time to steady state is going to be 2.7 hours times 4. Equals 2.7 times 4. So time to steady state
10.8.
equals 10.8 hours. Alright, so this means that you'll be at steady state after 10.8 hours of the first dose, or after dosing the tobramycin. So that means that all of your peak and trough calculations will be after, or will be around the second dose. Excuse me. Alright, so specific recommendation for tobramycin. So administer what was it? 415?
Yeah.
415 milligrams of tobramycin. IV daily. Draw peak.
No, it infused over 1 hour.
Oh, yeah.
Is it 1 hour or 30?
No, 1 hour. Over 1 hour. Draw.
Every 24 hours. You erase
Yeah,
it.
thank you. Every 24 hours. Draw peak. 1 hour after 1 hour infusion of second dose for a peak concentration of 18.07 milligrams per liter and draw trough 30 minutes before second dose.
Wait, why is it 1 hour after second dose?
So the time to steady state was 10.8. So that means that you give the first dose is time 0. Right?
Yeah.
So second dose is gonna be 24 hours, so you're already gonna be at steady state. So you do 30 minutes before and 1 hour after the infusion.
Because,
Correct. Yep. And then 30 minutes before second dose. For trough, yes, yeah, 1 hour after 1 hour. Yeah. Trough concept.
So basically, it's always gonna be 1 hour and then after either 1 hour or 2 hours, you're free, right? For like maple machine.
Yeah, yeah.
But it's always gonna be that.
So for aminoglycosides, it's always gonna be this. The aminoglycoside time of infusion doesn't change. It's always 1 hour. The only one that changes is Vanco. Vanco changes depending on your dose. I think there's a vancomycin's next, so.
Because the total is 2 hours, that's why you say 1 hour after 1 hour.
Right, yep, yeah. All right. Any questions in the chat? About how we wrote this, how we got to our answers, anything? Any conceptual questions?
Say that about it.
God bless me, that genetics, you know?
Yeah, you, thank you, Dad.
Yeah. All right, let's move on to the next question. Good? Good? Jesse, good?
Yeah.
All right, physician added vancomycin 1250 IV, Q 12 hours to treat central line infection. At steady state, levels were drawn, reported a peak of 37.5 at 1100 and trough of 26.5 at 0730. Dose was infused at 800. So calculate how long to hold the dose in order to achieve a trough of 15 milligrams per liter. So now we're getting into the individualized calculations. So you gotta solve for KE first. So KE will equal ln of peak, which is 37.5 over 26.5, all over the change in time. So the way that you calculate the change in time is the tau minus how much before you took the trough and how much after you took the peak. Okay, so everything is around this 800 time. So trough was drawn at 730. So and then the tau is 12. So you're gonna do 12 minus 0.5 because this is half an hour before. And then peak was drawn at 1100, which is 3 hours after 800. Yeah.
I remember, even within the exam, okay, I did something similar, but we didn't have to, it was just one number on the bottom. Do you remember what that was?
I don't remember exactly what you're talking about, but I remember there was a question on the exam where the nurse drew the level too late. So that's like when like knowing what this means is important because they can draw it whenever and you will still be able to calculate the KE,
Yeah,
sorry.
because I remember it was
Like she drew like 4 hours after or something like that, yeah. I don't know if that's exactly what you're talking about.
I think the question is asked is the one, how long would it take to foresee for drop down?
Yeah, so that's what we're,
That's what we only use one number.
yeah.
Yeah, I think.
Yeah, when the question they find the sheet drops and drop down below one.
I think that's what.
Remember we use that KE times. The E minus KE 2 hours.
Oh, yeah, this,
The
C3 goes C1, yeah.
To find KE, there's only one number at the bottom.
Yep.
It's a time difference.
Yes, yeah, the change, yeah,
That's what it is.
Yeah.
I have a quick question.
yep,
Okay, so calculate the change of time. If this patient is getting it every 48 hours, it would be 48 minus 0.5 minus 3.
absolutely, yep,
Thanks.
absolutely, yep. So everything revolves around the tau and stuff. All right, so what do we get for our KE calculation? Anybody get an answer?
It's 0.041.
That's what I got. 0.01. Is that what you guys got? Yep. Good stuff, Chanel. I checked it too. Perfect. Yep. Yeah. Are you checking it?
Yeah. That's what we
Everything's been right. KE is our minus. Okay. For units.
Yeah, hour -1.
All right, now that we have the individualized KE, we can calculate how much time it's going to take to drop to that level. So C2 is going to be our target concentration, which is 15. And then we have the peak here of 37.5. Times E to the negative KE, which is 0.041. And then we're solving for T. All right, so we do,
Jacob.
Yep.
Aren't you supposed to do 15 equals the drop?
no, I believe it's peak.
I also thought it was what you were doing, but I guess it's not.
Yeah, it is.
It's 26.5.
Because you're finding.
Okay, yeah, you're right. Sorry, yeah.
Drop.
Yep. Thank you. Yep. Yeah, because you're,
You find it like the second.
26.5. Thank you. Yep, so 15 equals trough. Just 1 second here.
Isn't it different for glycoside where you're supposed to use like the most recent value?
But it's not aminoglycoside.
No, I know this one's Danko, but for amino, what are you supposed to use the most recent value?
For what? Sorry, I just got.
But
Yeah.
most recent,
Isn't that what it
You
was?
put it down.
Yeah.
Good question.
most recent value of what?
Yep, so 26.5.
You're supposed to use like the most recent value for the aminoglycoside in this one, but it looks like you're not supposed to. For a Danko.
What do you mean? I don't know what you're talking about.
Never mind, I'll fix it.
Yeah, I don't understand.
All right, so the way that you do this is 15 divided by 26. So you get 0.57 equals E to the negative 0.041 T. And then to undo this, you have to take the natural log of both sides, ln. So you're gonna get negative 0.57 equals negative 0.041 T. Now we just solve for T, which equals 13.9 hours. Is that what you guys got?
Yeah.
All right, so before you write your recommendation on how long to hold the dose, you have to remember to add in how long your tau is. You have to add your tau back in. All right, so you do 13.9 plus 12 equals 25.9 hours. All right, so this is how long you're going to hold the dose.
Probably just round to 26.
Yeah, I'm sure it's fine. Yeah,
And we don't round up, right?
I don't think it matters, but I would just keep what you get.
Two of them.
Huh?
Round two of them.
Do
He
you?
did it in his.
Yeah, he didn't.
I think.
I don't think it matters.
He took both on the exam.
Yeah.
He accepts both because of the 29 an hour.
Oh, yeah, that's just because.
Yeah, that-
Yeah.
And
Thank you.
because what you're recommending,
Yeah, which is a big deal.
and he did accept both.
Yeah. Okay, so the way that we're gonna write a recommendation is that you need to, so hold. Vancomycin. Dose. 25.9 hours. After. Last dose. Given. At 0.800. To achieve. C trough. Of 15 milligrams per liter. Yeah, so Lisa, I think he took both answers on the last exam. Okay. Thank you, Chanel. Perfect, yep. Any questions? Comments, concerns?
It's been very nice.
Thank you.
We said comments. Well,
All right, moving on to the next question, get some individualized Vanco dosing. Okay, so calculate EE's new tau and dose to achieve your desired peak steady state and trough steady state. Okay, so remember when calculating tau for vancomycin, you use the equation that's ln trough minus ln peak over negative KE plus time infusion plus type T prime. So that T prime is just your time of infusion. Okay. All right, so tau equals ln. So your desired peak for vancomycin is 20 to 40, so you can just use 30. And then your target trough is 10 to 15, so you just use 12.5. Then you do plus. Yep.
when would that change? I know that the range for the C trail changes sometimes.
That's for aminoglycosides. Or no. Sorry, don't listen to me. No. For vanco, it's always this. Always. It doesn't change.
Always 10 to 15.
Always 10 to 15. Yep.
For that, okay.
Yep.
Yeah.
All right, time of infusion. So for time of infusion, what would we do 2, right? Because it was 1250
For which one?
per 6.
I'll see this. So for the grant. I don't, I was not making. Two.
Maybe it's the same.
All right, so we did 2 because the last for the population we did it was over a gram, and the time of infusion is 2 hours if it's greater than 1 gram. Plus 1 for the T prime, and again, remember again, the T prime is how long after the dose you're supposed to draw the trough or the peak. Huh? Yep. Yep. Thank you.
Question in the chat.
All right. 1 second over KE, which was 0.041. Huh?
That's the time of infusion.
So Veronica, this is vancomycin dosing. So I believe your MIC is always going to be 1. Because I believe there's somewhere in the slides where it says if your MIC is greater than is 2 or greater, you change the medication, you use vanco. I believe that's what it says in the slides. So I don't think the trough or peak will change for vancomycin. That's for aminoglycosides. And then for aminoglycosides, your trough will always be less than 1. And what will change is just that peak at steady state. So your peak at steady state, if your MIC is 1 for aminoglycosides, is 8 to 10.
1 or less.
Yeah, so vancomycin is not an aminoglycoside. Yep, that's correct. So for aminoglycosides, your desired peak at steady state is 8 to 10. But if your MIC is 2, you have to multiply that range by 2. So your desired peak steady state range is going to be 16 to 20. Right. Does that make sense, Veronica? All right, so for our tau, we can do the calculation. Yeah, listen. 2 hours. Yeah, so greater than 1 gram.
Is that greater or less?
It's greater. Well, you base it off what the population was. Yep.
It's.
All right, so what do we get for tau? Here for tau.
It's 24.
Yep. So, all right, so 24.4, we can just keep it. 24 hours is close enough. All right, so now, yes,
Are you talking about the 12? The 12 milligrams?
yeah,
That's fine.
right, exactly, yep, yep. Yep. Yeah, so the reason why we used 2 here for people who didn't hear us talking. So the reason why we use the 2 in this spot is because for population, we use 1250 milligrams. And then the range for time of infusion, if it's greater than 1 gram, you have to infuse it over 2 hours. So that's why we use that one. So everything is like related to the population. All right, so now we found the tau. Now we can find the new dose. So KO over time infusion equals C peak. So our desired peak is 30 times KE, which is 0.041 times the VD. So now we have to calculate the VD for the patient. So VD for vancomycin is 0.7 times actual body weight, which was 94.5. So VD equals
66.2.
Yep. 66.2 liters. So now we can plug that in here. 66.2 times 1 minus E to the negative 0.041 times the time of infusion. So like I said here, right, we're going to use the time of infusion of 2 divided by, oh, sorry, this one is the tau. My apologies. 24. 1 minus E negative 0.041 times the time of infusion, which is 2. So we also have to change time of infusion here. So it's going to be KO times 2 equals. So now we have to find what this equals here. 30 times 0.041. 662.
Oh. Jacob,
Yep.
we did VD wrong.
What do you mean?
We have to use individual base.
Yeah. we have-
Oh, yeah, my bad. Yep. So sorry. So since we're doing individual based, we have to use the individual based formula for VD. Sorry guys. So the individual based for VD equals KO time of infusion. So this is going to be based on the last one, correct?
Yeah.
Yeah, so we do 1250 over 2 times 1 minus E negative 0.041 times 2 over C peak actual, which was 37.5 times KE. Times 1 minus E negative 0.041 times the tau, which in that instance was 12, correct?
Yeah.
And then for our VD, we would get, let me know what you guys can calculate. You get for VD?
Yeah.
Yep, 82.4. So we go back here. Just plug in 82.4. Now we can calculate that. So what'd you get for this on the left, on the right side?
So I don't know, also.
I got 806.1. And then since it's infused over 2 hours, you have to multiply for the dose. So KO would equal 1612.3. What you got? And then what do we have to round the Vanco for? Is that the nearest 250?
Nearest 250.
So
1500.
Huh?
1500.
1500?
Yeah, or you can do one,
So it's about 125, right? That's
Yeah,
half.
120.
Yeah, so,
But make sure it works.
yeah, so
Oh,
KO,
that's what the next question is.
You don't have to do one list.
Well, the next question is all.
so KO would equal 1500, and that's infused over 2 hours. All right, so we have our new tau, 24 hours, and we have our new dose, 1500 milligrams over 2 hours. Make sense?
Yes, sir.
Yeah, so Christine, yeah. You're right, Christine.
If I use 48 hours, that fine.
So this is like what I was talking about before. So you get a close calculation. So I didn't do the 48-hour calculation. I just did the 24 one. So whatever you get, just check if it works. If it works, then you're good. If not,
Not the,
right.
the CP can see probe if it's within range, that will count. If you use 48 and the CP can see probe within range, then 48 is right answer.
I mean, that's what I usually.
Yeah.
Okay, so now the physician wants you to calculate the C peak steady state and C trough steady state using EE's rounded vancomycin dose. So our vancomycin dose was 1500. So C peak
Make sure you use the rate.
steady state equals. Steady state equals time dose over infusion. So 1500 over 2 times 1 minus E. The negative 0.041 times time of infusion, which is 2 over KE, which is 0.041 times VD, E, which is 82.4 times 1 minus E negative 0.041 times tau, which is 24. C peak steady state equals. Let me know what you guys get.
Possible. 7.9. Wait, why did you divide this by two?
Yeah, I got the same.
The time of infusion, yeah, time of infusion is 2 hours.
Yeah.
Oh, okay, okay.
The correct answer.
And then. That's 2.
Is that what?
Did you say this?
Yeah, you got the right answer. Wait, so why did you, so if the tau here is 24, or it's tau, why do you put 12?
This is based on the population dosing. So it was Q 12 hours
Okay, so it doesn't change.
when you're doing BD. Yep. Alright, so C peak, get 27.9. 1.
Yeah.
Milligrams per liter. And then for C peak trough equals 27.9 times E negative 0.041 times tau minus time of infusion, which is 22. C. What'd you guys get?
What's the peak
11
or trough?
32.
You're looking at peak or trough, right?
Trough.
11.32.
Big code here.
11.32 milligrams per liter. So this is good. We are between the 20 to 40 for the peak. We're between the 10 to 15 for trough.
Choose.
So Banco has to be rounded to the nearest 250 dose.
Think we should write it on the whiteboard.
Any questions?
But no, like 48 to 6 makes sense, because if it does.
Yeah.
So you can know. Then you can do.
Yep. I think your trough is gonna be too low if you do 48. Well, let me know. All right, we good to move on? Any questions on Zoom?
Yeah, we got it.
Hello. Hello,
Hello?
I have a quick question.
Yep.
So these are basically from the previous stuff, right? So it's like a mixture of the new and the old, right?
Yeah, so the final is a mixture of the old stuff and the new stuff. Yep.
Exam.
It's cumulative. So there's nothing from Dr. Kohan's section. It's only what Dr. Sun has been teaching. So nothing from Dr. Kohan.
Okay, thank you.
Mhm. All right, on to question number 8. Alright, after 5 days on atobromycin, his CM creatinine level is now 2.5 milligrams per deciliter. The physician is concerned about the tobramycin levels that were drawn and reported as a peak of 18.5 at 0800 and a trough of 2.8 milligrams per liter at 530. Dose administered at 0600. Calculate how long to hold the dose to achieve a trough of 1 milligram. Okay, so now we have to find the patient's KE, right? So individualized KE. So KE equals the ln of the peak, which is 18.5 divided by 2.8. And then he's getting an ODA dose of the tobramycin. So that's going to be 24 minus. So it's administered here. So we do minus 0.5 for the trough, minus 2 for the peak. So let me know what you get for the KE.
0.8.
Yep.
If you rounded the final answer for this first one. I think he's generous with that.
What'd you guys get for the KE? Yep. What's up, Angel?
So like you said, sorry, for the question before.
Yep.
You said the travel was gonna be too low.
Yeah.
Yes, it is. So I know he does it both ways. I know he changes the time interval, but sometimes he changes the dose. He goes to the next 250. Which is what he did on one of the examples. You can do either one
I would switch the tau.
now, just because it's so close.
Yep.
But I know for one of the
I
examples.
mean, at least I don't know, like if you, I'm sure you can do that, but you have to make sure that your peak is okay. Because if you start upping the dose, your peak is going to increase as well. You just want to make sure you're not going to.
Because I just know that for one of the examples I was doing the other day, it came out to be 1073, and he just went he did 1,000, that didn't work. So then he went up to 1,250, that also didn't work, and then after that, he switched back to 24, so 48. So
All right, so KE is 0.088. So now we can calculate how long to hold the dose. So our goal trough is 1. Our current trough is 2.8 times e to the negative 0.088 times t. And then you want to solve for t. Let me know what you guys get for the time. You get
11.7.
Yep.
And then at 24 to hold.
So 11.7 for the time, and then for time to hold the dose, you have to add 24. It's be 35.7 hours. So hold,
For his answer, he rounds to.
he rounds, yeah.
To 36.
So both ways, yeah, either or. Yeah.
As long as it makes sense.
Yep.
Like, you can also round to. Like, say if there's 0.5 at the end, like you could just keep it like that.
I think that in class, I remember him saying that it's also good to round the time because it's easier for the nurse.
Yeah, cause they're not gonna like be like, oh, after like 9 minutes or whatever it comes
Yeah.
out to.
35.7.
But yeah, for recommendation.
We'll do the rest of those for 35.7 hours after last dose given at 600. Any questions? Comments, concerns? Different answers?
Looks good. I like it. We should have ordered like 6 pizzas. That's why I said sugar.
Assume guys, you good? Any questions? All right, moving on to question number 9. All right, EE has received your recommended maintenance dose of phenytoin that you calculated in question 1 for 7 days. His levels came back to be 6.5 milligrams per liter. Calculate his new maintenance dose to achieve a C peak steady state level of 15 milligrams per liter. And state your specific recommendation for EE, including doping. All right, so for phenytoin. All right, so for, let's see what we got here. So for question 1, they received that, and now
Their maintenance was 600.
yeah, sorry, their maintenance was 600 of the ER capsules. So the first thing we have to do is calculate Vmax. And this equation is on our answer sheet, or on our equation sheet rather. So Vmax equals XO, so that's the dose that we recommended. So that's 600 times the S value. So since that's the oral extended release capsules, the S value is 0.92. Times Km, which is 4. And that's stated on the equation sheet as well. Plus C peak steady state observed. And in this case, his levels came back to be 6.5. Divided by C peak observed, which is 6.5. All right, so our Vmax equals, let me know what you guys get.
I got 891.7.
What you get again, Abdullah?
891.7.
Yep, I got 891.7. Km is 4. That's the Michaelis-Menten constant that's given to us.
Okay.
It's always 4. What, Vmax?
Yeah.
I think it's liters, maybe. I'm not sure.
Well, let's look at our units.
Yeah, if you want to look at that, Alex.
Meg per liter.
Meg per liter. Meg per liter. Okay. There was a second here.
Yep. He has it as milligrams per day.
Is it milligrams per day?
Is that empty?
Yeah, Vmax is
Yeah.
Mg per day. Okay, mg per day. Okay, so now that we have the Vmax, we can calculate our new dose. So new dose is XO times S equals Vmax, which we calculated to be 891.7 times desired C peak steady state, which in this case is 15. Divided by the Km, which is 4, plus C peak desired, which is 15. So remember, the S value for the extended release capsules is 0.92. So let me know what you guys get.
For the first part, I done 703.97.
703.97. So if you were doing the this gives you like the free form, the free acid form, this right here. But since you're giving the ER capsules because it's maintenance, you have to divide further by 0.92 to get your final XO. And what do you get for your final answer?
765.
All right, 765.2. So remember, we have to make the dose available in the formulations that we have. So the extended release capsules come in either 100 or 30 milligram options. So we can just round this up to 800.
400 BID.
Up,
And 400 BID.
800 milligrams per day. So remember, anything above 300 needs to be split. The max that you can give in a split dose is 400 milligrams. So our recommendation would be for give for, or I think it's take, right? Take for 100 milligram extended release capsules, 400 milligrams by mouth, BID.
He also has, you can take 300 in the morning, 200 in noon, and 300 at night. Yeah. Or the 400, which is what I.
Yeah, so let's see. Yep, perfect, Lisa, good. Any other questions about this problem? So I just wanted to mention something. So on the answer key for this problem, he said that you could also recommend the patient to take 300 in the morning, 200 at noon, and then 300 at night. But you can also just do 400 milligrams BID. So I would just keep it simple. There's less room for error. Just keep it at 400 BID.
Okay, so I'm sorry.
So you can break up the dose however you want. Just I would just keep it as simple as you can to make less room for error.
Then could you do? I don't know if that's what made it make sense. Could you do 760?
Yeah, so you could do 760, but the thing is the patient has to remember, like you're giving different like values. That's the thing.
Gotcha.
And it's gonna get funky with them giving it to themselves.
Also, like if insurance doesn't cover.
Yeah.
300, or the 30, then they only cover 100. Yeah, just keep it as simple as possible, it should be fine.
The patient's gonna make mistakes, so they're taking them as a bunch of down.
Generally, just rounding to 100.
Yep.
You'll be fine, unless you
Darnell
specifically
Mooney's
want.
going on. Darnell Mooney's going on.
I'm not looking at him.
All right. Any questions on this problem before we move on? People on Zoom, people here, any questions? Good. Yes, you good?
Yeah.
All right.
Oh, man, you're one way.
FB is a 94-year-old male, 5'6", 63.6 kilograms with a current serum creatinine of 3.3 milligrams per deciliter. FB has been on vancomycin 750 IV, Q36 hours. Last dose was 1126 at 1200. His KE equals 0.015. His trough level was drawn too early on 1127 at 1200 and was reported at 22.4 milligrams per liter. Calculate what his actual trough would be if it had drawn half an hour before the next dose. All right, so let's break down what we have here. So his trough level was drawn too early. All right, so last dose was 11:26. It was drawn on 11:27 at 1200. So it was drawn after 24 hours. Uh, so if we know that it was drawn after 24 hours, we can treat this as like a kind of like a peak, I guess, like a new peak. And what we can do is we want it, so since he's getting it every 36 hours, we want our peak to be 35.5 hours after last dose. So what we can do is we can do 35.5 minus 24 gets 11 hours, 11.5 hours.
It's 236 and 30.
It's, yeah, it's Q26. So when they drew the last peak, it was 24 hours after. We want it half an hour before their next dose.
That's for trough.
Right, yeah, so we're like, so they're in a trough, but we want to go further into that trough. You know what I mean? Yeah,
5.5 plus 236.
you're kind of like, you're treating it,
It's the trough,
Yeah, it's drop.
yeah, that's the trough that they calculated, but it's wrong. Because the nurse made a mistake.
so you're doing 35.5 like the trough.
Right, so this is when when you're supposed to draw the trough, the 35.5, because it's half an hour before the dose. All right, so what we can do is we have our C desired here equals our trough that they drew, which is 22.4 times E to the negative 0.015 times 11.5. So let me know what you guys get. You guys do that? What'd you get?
18.
Yep. 18. 5. And then is this appropriate for vancomycin?
Yeah.
Perfect. What is it? Vanco?
Yes, no, it's
Vancomycin?
not appropriate.
Yeah, not appropriate, but it doesn't ask if it's appropriate or not, so.
Yeah.
Can you go back to where you got the 35?
The what?
The 35.
Yeah. So the patient is getting it every 36 hours. So if they draw it correctly, you're gonna draw the peak at 35.5 hours after the last dose.
The 30.
Or the trough, yeah, sorry, the trough.
Right,
What'd you say?
30 minutes.
Right, it's 30 minutes, right, exactly. So it's 30 minutes before, so the time that's passed is 35.5 hours. Make sense? Good, yep.
You do minus 24.
Yep, so we did minus 24 because the time that they drew the incorrect trough was 24 hours after the last dose, which is right here. Any questions how we got that answer on Zoom?
It's perfect on answer.
Yeah.
Perfect. All right. Moving on. Oh, got a question. Hey, what are you confused about with Lisa? Had too much thinking, yeah.
Yeah, I would just look at this. I'm like, oh, I can't figure this out. Move on to the
Yeah.
next question.
Yeah, if you ever, the thing if I ever like read a question and I like have no idea what to do, I just skip it because it's better to get the points that you can get and then just go back to whatever you can afterwards.
Right, so this would be one of those because we never have enough time in this exam.
Exactly, yeah, just skip it and I think you said that What, we're gonna get like, I forgot exactly how many questions he said there would be, but I think it worked out to be like 4 minutes per question or
It's like
something.
28 question.
28 questions in 2 hours. All right, now 100 minutes.
You basically already
2
did.
hours.
Oh, it's 2 hours.
It's 2 hours, yeah, so
There's one other guy was now.
you should have plenty of time.
Yeah.
Gauging on your previous exam, because there's about the same amount of questions, but now you get double the time, so.
All right, RI is a 74-year-old male with atrial fibrillation. Rapid heart rate of 130 BPM. So let's calculate his creatinine clearance. So, yep,
I have a question about, question before,
yep,
is it? Like, just to make it simple, like you was just look at the time interval and then you just do like the minus,
0.5. And that's when you're supposed to draw your trough.
and then just plug in the numbers in.
Should be good. But the thing is, you have to like subtract 24 from it because that's right, because they didn't give you a peak. If they give you a peak, then you could ignore the trough.
So the only thing that should change should be the time interval. Everything else, like, then you're just gonna do, like, if it's 24, then you do, 23.5
Correct.
minus. what- Oh,
Or minus whatever the incorrect
Right,
was. Correct, yeah.
Okay.
Good, yep. Okay, so let's calculate his creatinine clearance. So we have to find his ideal body weight. IBW for a male equals 50 plus 2.3 times 10. So IBW equals 73.
Is it that Johnson?
Yeah, this is the Jackson.
Creating clearance, you will adjust it, but for that to say.
Yep.
You have to
Use ideal. Always use ideal.
Yeah, for creating clearance, you have to
Yep.
adjust it.
You always use ideal unless their actual is less than ideal.
The creating-
All right, his weight was 213. 213 divided by 2.2 equals
That's a few IBW.
96 point.
The other
Eight.
was
So
Rango.
All right, 73 times 1.3
For aminoglycoside and for dialysis.
equals 94.9,
I mean, not.
which is less than 96.8. So that means that we have to use adjusted for this problem for creatinine clearance. So adjusted body weight equals ideal plus 0.4 times actual minus ideal. Adjusted body weight equals, let me know what you guys get.
Yep. 82.5.
Yep, 82.5. 82.5 kilogram. So now we can do creatinine clearance. Equals 140 minus 74 times 82.5 over 72 times serum creatinine, which is 2.1. CrCl equals, you know what you guys get? Yeah. 36. His answer key is wrong.
What would he put it to?
He used 203 for the weight.
Oh, that's the one he said he was trying to change, I think.
Yeah,
Yeah, I read it.
yeah, he did.
Of course he did.
Oh, what'd you guys get for the adjusted body weight again?
82.5.
Okay.
Sorry.
Buffalo chicken wings.
You guys got 36 for creatinine clearance? All right, creatinine clearance equals 36.0. All right. Recommend an IV digoxin loading dose to achieve a peak of 1.5 nanograms per milliliter. All right. So for the Johnson loading dose. We need to find VD before we do anything, so VD equals 7 times ideal body weight, which is 73 in this instance. So remember, it says ideal body weight, so you always use ideal body weight, regardless if we have to use the adjusted for creatinine clearance. The only time you wouldn't use ideal body weight is if their actual body weight is less than the ideal. Then you would use their actual. It's the only time. All right, so for VD, we would get. You guys get, huh? 511? What's the unit on that? Liters. Liters. Okay, now we can find the loading dose.
Convert to mils.
Yep, so when doing loading dose, we do our C peak desired, which in this case is 1.5. And when calculating loading dose, we have to change VD into milliliters. So you have to do 511 times 1,000.
Or nanograms. Yeah.
Yeah,
Do you know why would you?
didn't explain it. I have no idea. That's just, we have to do it to make the math work.
Mils because your other units are already in mils. So.
Yeah.
I mean, you can change those ones, but just change it, you'll.
Probably because so CP is nanograms per milliliter. So we need the milliliters to cancel each other out and get nanograms. Yep. That's, but he never explained why. Times, loading those times F, which is, so the F for the oral tablets
Yeah.
are 0.75. So 0.75 times 10 to the 6. And this is all on, so you have to remember the F values for the different formulations of the Jackson. But this equation, the loading dose equation is on the equation sheet. You have to remember what the VD equation is.
So I think it's 1.
No. It's if you were using IV. If you were using IV, then it would be 1.
No, I think you are using IP.
Huh? Is it asking for IV?
Yeah.
The jobs.
Oh, sorry. Yeah, okay, my bad, guys.
E
Yep,
is IV.
thank you.
C is
Yep.
the.
Okay, yep, so we're doing IV, so F would be 1. All right, so for loading dose, IV. Let me know what you guys get.
I got 0.76.
0.7.
6.7, and then you can round to 0.75.
Yep.
Yeah, I did 0.7.
Yep, so remember, we have to make sure that it's available in the formulation.
Okay.
So we would do 0.75 nanograms. Right? Make sense? Milligrams, sorry, milligrams.
Yeah, makes.
And the max is 0.5.
Yep.
Yeah.
So when giving instructions on how to give the loading dose, remember that the max that you can give in a loading dose is 0.5, all right? So the way that we would do this, so the IV formulation comes in at 0.25 milligram per milliliter vial. So 0.25 milligrams per liter. So in order to get 0.5, we would need 2 milliliters.
You have to say it's.
Yeah, that's what
So the way that you would instruct the person to give this is you would do infuse
Yeah, that's.
2 milliliters
0.7.
of IV digoxin. Now And give 1 ml. Give 1 ml. In 6 hours. Make sense?
That's right.
That's the only interval, right?
Yeah, it has to be 6 hours. Yeah, it has to be 6 hours.
The difference between like the gold dose has to.
Yep.
be sure.
Any questions on how we did the IV dosing? All good? Right. C. All right, C, calculate an oral maintenance dose of the digoxin to achieve a peak of 1.5. All right, so for the maintenance dose, we have to find the CL total. CL total, which equals 1.303 times creatinine clearance, which we calculated to be 36. Plus CL met. So for CL met, this is the clearance of metabolism. So for patients with no to mild heart failure, it's going to be plus 40. None to mild. So this includes AFib and hypertension. You're going to do plus 20 if they have moderate to severe heart failure. Moderate to severe heart failure, which is congestive heart failure. All right. So in this case, the patient has AFib, so we would do plus 40. So CL total equals
86.9.
I also got 86. His answer sheet is wrong. But
yeah.
For the.
Yeah.
Yeah, he listed up and then he told us that he's always right, so.
No, he did that jokingly.
All right, equals 86.9. Good. So we all got 86.9. Flynn, the 1.303 comes from the equation sheet for the CL total. All right, now that we found the CL total, we can now plug it into the digoxin maintenance dose calculation or equation that we have on our equation sheet. So X for our dose equals our desired concentration, which is 1.5. Times CL total, which is 86.9 times 100 or 1,440. So remember, this is our tau. So since we want to do once a day dosing, we would do 1,440. If it asked for a dose every other day, if they wanted to take it, so take it one day and then skip a day, this number would change to 2,880. This is all over F. So in this case, they want oral tablets. So like I was mentioning before, it's going to be 0.75 times 10 to the 6th. All right. So for the dose, let me know what you guys calculate.
One. Two, PO.
All right, what you got? Yep. So our daily dose would be 0.25. All right, so our available dosage forms for the tablets. They come in 0.125 and 0.25. And remember, both of these tablets can be split, so it is possible to give a dose of 0.065 as well, or 625. All right, so this is easy for us. All we have to recommend is take 0.25 milligram tablet by mouth daily. Any questions, comments, concerns? Stuff Chanel. Questions, comments, concerns?
The only question I had a couple of people messaging me to see if the recording would be available.
Yep, yeah, so we're recording it right now. As soon as it's done, it should save to the computer and then I'm gonna upload it to YouTube. And then I'm gonna send out a link, or Cam will send out a link to the entire pharmacy DLP in-person cohort thing.
Awesome, thank you.
Absolutely, yep.
That was a great review. I appreciate it.
No worries. It'll probably take a couple hours to upload just because it's been like 2 hours of work, so.
Okay, cool. Thank you.
Absolutely.
Is it gonna be uploaded on Kodiak?
No, it's gonna be uploaded onto YouTube.
On
So-
what?
We'll send out the link, don't worry.
Oh, okay, thank you.
Yep.
Do you have a YouTube channel I don't know about that I could subscribe to?
We, not really for this, but, I think
Trick shot videos.
we did like one other review. I don't remember, I think it was for the first PK exam. We uploaded it to that. Anytime we upload anything, it'll just go to the same YouTube channel.
Exactly. That's why. Give me the link and I
yes,
would.
yeah, when you get the link, I'll just, you can just subscribe to that channel that's uploaded to. All right,
Thank you.
All right, thanks, man.
no worries.
I think
Good
you
luck,
should tutor us for
everyone.
all of our classes.
What's up?
So I think you should tutor us for all of our classes.
I wish there was more time between, we could.
We have one for MedChem.
Huh? Medchem?
Yeah.
That's Wednesday night's gonna be rough. It's gonna be a late night.
I'm thinking big deal.
And apparently it's gonna be 60% the old stuff and 40% the new stuff.
Yeah,
So it's a lot of whatever we learned before.
same thing for Dr. Hong. I think Dr. Hong is like splitting stuff up like that. Like it's gonna,
Dr. is 50-50.
oh, is it 50-50?
50 old, percent old
Yeah.
exam questions, which are just, he's taking.
Yeah.
Exam. He's either gonna modify them slightly, so be sure to read them.
Yeah, I would
And blindly pick.
for Dr. Hong, I would definitely, he opened up all of our exams. So if you go back in there, look at the questions, I'm sure the problems he pulls from other exams are gonna be almost identical or just changed a little bit. So just be comfortable with those problems.
50% is on the new cardiovascular. He made an announcement on how.
Yeah.
Double check reading over that from this specific, what he recommends.
Any other questions, guys?
No, I think that's it. Good luck, guys.
All right, thank you. Good luck this week, guys.
Good luck.
If you have any questions, feel free to reach out to me or Cam.
All right.
All right. Thank you, guys. Alex, how should I stop this?
You should just hit, stop recording.